This is part of the section 4.4, and we're solving or proving that triangles are congruent by side, angle, side. What it says is that two triangles can be proven that are congruent by two sides and the included angle. So before you fold it over on this back side, if you'll write something for me, we first need to know what congruent triangles are. And congruent triangles are two triangles that have everything equal. That would mean that sides, all three sides are equal. To a corresponding side of the other triangle. They don't have to be the same side, the same size, but all the sides have a corresponding side that is equal to the other. They also have to have congruent angles. So I'm going to put angle measurements, so 30 and 30. And then I'm going to note like this for 90, and then 60 and 60. To be congruent means that all the sides and all the angles are congruent. Well, you need to know that because for this section, all we need is to prove it is side, angle, side. So all of them will be using side, angle, side. What does it look like? So even if the pictures are rotated or the triangles are rotated, we still have a side that corresponds with another side. For this particular problem, I'm going to say that this side is also congruent to this side. Well, how do I know which one's which? Some of you will need to rotate the picture to be able to tell that it's the same. So this is the shortest side that corresponds with the shortest side. And then the longest side that corresponds with the longest side. The included angle is the angle that is created by the sides you just said were equal. So I always like to call them sandwiched. That angle that is sandwiched by the sides that you just indicated were equal. They are the ones that are being created by the sides. Once you have that side, angle, side, you can say that the triangle ACB is congruent to the triangle. And this is important, the order of the letters matters. See, if I go from A to C, it gives me that hash mark, that just one hash mark to indicate that it's equal. That means I have to go from E to D. And then from C, the one that is congruent to D, I have to go to B. So CB means that D goes with F after F. And the two sides that have the hash marks. So I'm going to underline it just so it's a little bit clearer what I want. CB has to correspond with the side DF. So you can know that those are the parts that go with each other. All right, let's take a look at the proofs. Some things that you need to remember. Midpoint cuts things exactly in half. The definition of midpoint is what you need to use to say that the two segments are equal. You also know that vertical angles are congruent. On this picture, what I want you to be able to see is that you can separate this triangle. Well, that's the ugliest triangle. And where this is KNM. And I can separate the other triangle over here NML. And that should help you with the proof. one thing that is very important is that the side NM is shared by both triangles. You also need to remember what the reflexive property is. The other thing that I would like for you to remember is that when things are perpendicular, the angles are 90. There was a theorem a long time ago that said all right angles are congruent. We're going to call that one right angle theorem. Okay, on this next one, what you needed is to remember that we can separate the two triangles. I have this one on the bottom, and I'm going to separate it to the one on the top. And that they share this segment GJ. They share the segment GJ. So you're going to need to remember what the reflexive property is. The other thing that I want you to remember is these two angles are called consecutive interior. Consecutive interior. How do I know? Here's the parallel lines cut by that transversal. They're inside, and one's on the top and one's on the bottom. Consecutive interior angles. And that is a theorem that says that they're also congruent. On this one right here, what you need to remember is what bisector means. Bisector also cuts in half. That means that the two segments or angles it cuts are now equal. So I'm going to make the notation this way. The two angles are now equal, thanks to the definition of bisector. This triangle also can be separated from the one on the top, QS, from the one on the bottom, with QS. Your assignment will be to finish these proofs.